Hello student, how are you? In the next lecture of the chapter 2, inverse trigonometry function, let's prove that the sine inverse 2x into under root 1 minus x square is equal to 2 sine inverse x. So where the modulus x is less than 1 by root 2. So it's a new type of question and the most important question. See, what we have given for the modulus x less than 1 by root 2, we have to prove this. So there is a one rule for this type of question. So what is our answer we needed in the right hand side? 2 sine inverse x. So assume this as a theta. So let sine inverse x is equal to theta. That means sine theta equal to x. Sine inverse x equal to theta, that means sine theta equal to x. So now 1 minus sine square theta is equal to 1 minus x square, right? If we are doing the square on both the sides, and 1 minus sine square is equal to 1 minus x square, and we know that 1 minus sine square is cos square theta, and that is 1 minus x square, and if we are taking square root, it is 1 minus x square's root. So root of 1 minus x square equal to cos theta. Now for our left hand side, what is the left hand side? Sine inverse 2x 1 minus x square. Sine inverse 2. What we have assumed? X equal to sine theta. So x equal to sine theta. And what is the value of 1 minus x square? That is cos theta. So now sine inverse 2 sine theta cos theta is sine 2 theta. Now we know that this sine inverse and sine will cancel. Answer will be 2 theta. But what is the condition? For that this theta must be in the range of sine inverse means minus pi by 2 to plus pi by 2. So we have to prove that 2 theta lying between minus pi by 2 to plus pi by 2. Then we can cancel it. So now to prove that 2 theta belongs to this. So what is our theta? Theta we have taken, not given in the question. So theta is depend on x, and x has a condition, it's less than 1 by root 2. So modulus x is less than 1 by root 2. So here modulus x is less than 1 by root 2. That means minus 1 by root 2 less than x less than plus 1 by root 2. Now x is our sine theta. X is our sine theta. Now we have to convert this function or so this inequality in terms of theta or in the sine format. So minus 1 by root 2 is written as sine minus pi by 4 less than sine theta, and less than it is sine pi by 4. So 1 by root 2 is sine pi by 4 and minus 1 by root 2 is sine minus pi by 4. So now sine minus pi by 4 less than sine theta less than sine pi by 4. And we have earlier discussed in the 11th standard, the sine is increasing function. So what is the increasing function? So if two variables x1 and x2, the comparison between two variables x1 less than x2 and f of x1 is less than f of x2. So that means if we are applying any function over that variables, the inequality has no any changes is there. So in that case it's called f is increasing function. Both the way. If f1 x1 less than f of x2 and x1 less than f of x2, then we can say that f is increasing function. So we know that sine is increasing function in a second and third quadrant, first and fourth quadrant. In fourth and first both the quadrant sine is increasing function, and when function is increasing, we can remove f and we get this inequality. So in that case we can remove sine. So minus pi by 4 less than theta less than pi by 4. So from the functions inequality we are going to the variables inequality. So here the inequality between our function, and here we have converted it into a variables. So now what is our condition? 2 theta. So multiply it by 2. So it will be pi by 2 less than 2 theta less than pi by, and that is the condition for removing sine inverse and sine. So 2 theta lying between minus pi by 2 to plus pi by 2, then we can remove. So by equation 1, left hand side equal to sine inverse sine 2 theta. That sine cancel, we have a 2 theta. And what is theta? Theta is sine inverse. So that is right hand side we have to prove. Just you have to let's go through this. Then it's very easy. Let's see the next example. Second one, cos inverse 2x square minus 1 equal to 2 cos inverse x, where (1 by root 2) less than x less than 1. Now see, what is here? 2 sin cos inverse x. So let cos inverse x equal to theta. So x equal to cos theta. Now left hand side, cos inverse 2x square minus 1. Cos inverse 2, x is cos theta, that means cos square theta minus 1. Cos square theta minus 1. We know that 2 cos square theta minus 1 is the formula of cos 2 theta. Now stop here. We have to check now 2 theta is in the range of cos inverse. And what is the range of cos inverse? 0 to pi. Range of cos inverse is 0 to pi. We have to check this. So now for that we have to use this condition, 1 by root 2 less than x less than 1. Now what is the value of 1 by root 2 for the function cos? Cos pi by 4 less than, x is our cos theta less than, and 1 is the value of cos 0. Now see, it has a 1 0 0 1, and somewhere here 1 by root 2 1 by root 2. See, x coordinate denote the value of cos theta and y denotes the value of sin theta. In the first quadrant, cos become 1 to 0. That means cos is decreasing function. Cos is decreasing function. In the first quadrant, it going 1 to 0. and here it become minus 1 to 0 means 0 to minus 1. That means 1 and 2 quadrant, first and second quadrant. Cos is decreasing function, and whenever the decreasing function is there, that means x1 less than x2 implies f of x1 greater than f of x2. That means inequality are changed. So you remove the function, you get the different inequality from in the variable, and if in a variable there is a less than, when applying the decreasing function, inequality will change. So here 0 to pi by 4, that means theta first quadrant, theta is in first quadrant. So cos is decreasing in first quadrant. That means that pi by 4 greater than theta greater than 0, means 0 less than theta less than pi by 4, and we need a 2 theta, so multiply with 2, it become 2 theta less than pi by 2, means 2 theta lying between 0 to pi by 2 means first quadrant, and we have condition first, anyone, first or second quadrant. So by second one and first one, so by 1 and 2, left hand side equal to 2 theta. If 2 theta lying in 0 to pi means first or second quadrant, cos cancel. See here cos inverse and cos cancel, answer will be 2 theta, and 2 theta is lying between 0 to pi by 2 means this condition of the range is satisfied. That means 2 theta and 2 theta equal to cos inverse x, and that is our right answer that we have proved. Similar type of question may be asked for a tan 3 theta, sin 3 theta, cos 3 theta. Let's discuss about the 3 thetas question. Let's next example. Sin inverse 3x minus 4x cube equal to 3 sin inverse x, where minus 1 by 2 less than x less than 1 by 2. Similarly, what we have to assume? Let sin inverse x equal to theta, x equal to sin theta. Now for left hand side, sin inverse 3x minus 4x cube, sin inverse 3, x equal to sin theta. This is 4 sin cube theta, and this is the formula of sin 3 theta. Say it is 1. Now what we have to check? That 3 theta in the range of sin inverse means pi by 2 to plus pi by 2. If this is in the interval minus pi by 2 to plus pi by 2, then these both are cancelled. So now for minus 1 by 2 less than x less than 1 by 2. So now what is the value of 1 by 2 for a sine? It is sine minus pi by 6, and x is sine theta, and 1 by 2 is sine pi by 6. So we have to given the value 1 by 2 minus 1 by 2 less than x and 1 by 2. So we have to convert that 1 by 2 in the form of sine. So for which angle sine will be 1 by 2. So now we know sine is increasing function. So less than theta less than pi by 6. Now what is the multiple of theta? 3. Multiply with 3. So pi by 2, 3 theta, pi by 2. So 3 theta lying between minus pi by 2 to plus pi by 2. So by 1 and 2, left hand side equal to 3 theta. These two are cancelled, and 3 theta is equal to sin inverse x, and that is right hand side. Theta equal to sin inverse x, and that we have to prove. Understand? once go through these examples, and there's some examples given or illustration given in the textbook. Let's check that and then try to solve another examples. We are discussing new examples also. So let's fourth, tan inverse 1 plus x square minus 1 by x equal to, they just simplify it, x not equal to 0, equal to dash. Simplify it, find the value of this function or simplify it. So here tan inverse 1 plus x square minus 1 by x, tan inverse. In this type of question we have to assume some value of x. So such a value we have to assume, due to that we can simplify it easily. So what we will assume as a x in the terms of trigonometry function, then 1 plus x square's root can be possible. So let x equal to tan theta. So 1 plus tan square will be sec square, right? So let's x equal to tan theta. So 1 plus tan square theta minus 1 upon tan theta, bracket, let x equal to tan theta. Now tan inverse 1 plus tan square means sec square theta under root minus 1 tan theta. So tan inverse sec square under root is sec theta minus 1 upon tan theta. Right? Now convert it in a sine in cos. Convert this in a sine into cos. So 1 by cos theta minus 1 upon sine theta upon cos theta. Taking LCM on both the side, numerator and denominator, 1 minus cos theta. Denominator cos will be cancelled. Sine. Now 2, 1 minus cos. 1 minus cos theta equal to 2 sine square theta by 2, and sine theta is 2 sine theta by 2 cos theta by 2. Half angle formulas, 2 1 sine cancel, tan inverse sine by cos, tan theta by 2, tan theta by 2, theta theta cancel, because range of tan is, domain of tan is R. So there is no worry about that. So tan inverse cancel, it will be 1 by 2 theta, and 1 by 2 theta equal to tan inverse x. Tan inverse x, theta equal to tan inverse x. Clear? So this is the simplified form of this question 4. Got it? Now try to solve exercise 2.2. Exercise 2.2. See next example. It's a most IMP example. It has so many type questions involved in this examples. Sometimes it may be asked like 1 plus x square, 1 minus x square, 1 plus x, 1 minus x. Instead of minus, denominator has minus and numerator has plus. So somewhat changes is there at the end of the questions. Remain all this type of question can be solved by a similar way. So now see here, tan inverse 1 plus x minus 1 minus x, 1 plus x plus 1 minus x. So tan inverse, let x equal to cos theta. X equal to cos theta. So 1 plus cos theta, 1 minus cos theta, 1 plus cos theta, plus 1 minus cos theta. Let x equal to cos theta. Now divide numerator and denominator by 1 plus cos theta as root. So first one, divide by this 1 minus cos theta upon 1 plus cos theta under root. Numerator and denominator is divided by this one, 1 plus cos theta's under root. So it will be 1, it will be also 1 plus 1 minus cos theta upon 1 plus cos theta divided by root 1 plus cos theta. Numerator, denominator divided by 1 plus cos theta's under root. Now see, you are getting any point from this? 1 minus cos theta upon 1 plus cos theta. What is the formula for that? 1 minus cos theta upon 1 plus cos theta is nothing but tan square theta by 2. If you have not remembered the formula of trigonometry, you didn't solve the question. You will not solve the question. So first of all, you have to remember all the formula of chapter 3 of trigonometry function of 11th standard. Under root tan square theta by 2, under root tan square theta by 2, if we are removing the root, what is the answer? 1 minus tan theta by 2 and 1 plus tan theta by 2. So tan inverse. Now for that, in the last lecture we have seen, so 1 minus tan theta upon 1 plus tan theta is nothing but tan pi by 4 minus theta by 2. Simplifying of this is this. In last lecture we have discussed tan 1 minus tan theta upon 1 plus tan theta is tan pi by 4 minus theta. So here theta by 2, pi by 4 minus theta by 2. Now tan cancel. Answer will be tan pi by 4 theta by 2. Now substitute the value of theta 1 by 2 and theta is cos inverse x. Pi by 4 minus 1 by 2 cos inverse x. This is our answer. It's the most IMP question. Suppose instead of that x, we have given x square. So let x square equal to cos theta. Assume x square equal to cos theta. Remain it same. Here cos inverse x square. Nothing else. Same to same. Instead of x, if we have given x square equal to cos theta, we have to assume x square equal to cos theta. Remain all step are same. At last, when we are substituting the value of theta, it will be cos inverse x square. Got it? Let's see now next example. See exercise 2.2 question 4. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 equal to tan inverse 31 by 70. So let left hand side equal to 2 tan inverse 1 by 2 plus tan inverse 1 by 7. We have a formula of tan inverse x plus tan inverse y, but no for 2 tan inverse x. So instead of that 2 tan inverse, we can write it tan inverse 1 by 2 plus tan inverse 1 by 2. Means 2 times tan inverse 1 by 2 plus tan inverse 1 by 7. Now add them. Tan inverse x plus tan inverse y. So tan inverse x plus y upon 1 minus x into y plus third step is as it is. In last lecture we have discussed this formula and we have discussed some examples of that also. Tan inverse x plus y 1 minus xy. Condition mod xy is less than 1. Here 1 by 2, 1 by 2, 1 by 4. So 1 by 2 into 1 by 2 is 1 by 4 less than 1. That's why we have using this formula. Now simplify. 1 by 2 plus 1 by 2 means numerator has a value 1. Denominator 2 2s are 4, 4 minus 1, 3 by 4 plus tan inverse 1 by 7. Now tan inverse 4 by 3 plus tan inverse 1 by 7. Now again same formula. So 4 by 3, 1 by 7, 4, 7 3s are 21 less than 1. How we can say it is value less than 1? Numerator is less than the denominator, value will be less than 1. Numerator's value is less than denominator, the whole value will be less than 1. Numerator is higher than denominator, then value greater than 1. So here numerator is 4, denominator 21, so less than 1. Now add them. So it is tan inverse 4 by 3, 1 by 7, 1 minus 4 by 3, 1 by 7. Simplify it. Tan inverse 7 4s are 21 plus 3 1s are 3 in denominator 21. 7 3s are 21 minus 4 upon 21. Denominator 21 cancel. Tan inverse 28 plus 3 31 and this is 21 minus 4 is 17 and that is our right hand side. Clear? So whenever the multiple of tan inverse is given, so we have to take this value as much as this times, 2 times. So add them 2 times. Sometimes it's given 3. So tan inverse 1 by 2 plus tan inverse 1 by 2 plus tan inverse 1 by 2 and then simplify it. Okay, now you have to solve the illustration before exercise 2.2 and then try to solve exercise 2.2. Remaining question we will do in a next lecture.